Okay, let's look at connecting the gear now. I'm going to share my screen and bring up my software. Uh, I do have two kits set up. We're only going to connect one and get it operational. And the one we're going to connect is the one connected to the Vixen. At the top of the page, I've got these laptops named to keep it straight in my mind when I'm doing on-the-fly programming. But Astro 2, the ED81S Vixen, and let me bring up my outside camera, the surveillance camera that we talked about, and this is the kit that we'll be activating. This one is also set up, and I'll fly over to that one very quickly, and that is 1 second. That is this one, and that's Astro 1, and that's the stellar view that has the 70T attached to it. So actually we're on this one. Let's just go ahead and connect this one. So I'm going to bring up, the first thing I'm going to bring up is my Pegasus power box. That's that blue box, and it has the data and the power connected data from all of the devices, the mount, the camera, the focuser, and all require power, and they require data connections. And then there's only one data line that comes from the power box to the laptop, and one power cable that comes from the power box to AC. And so I only have two cables coming out of the kits for each one. Let's go ahead now and connect, and I'm connecting AC now directly to the power box, and it's now going to, I'm going to turn on the mount, I'm going to turn on the focuser, and I'm going to turn the camera on, and so I can see the amperage that each unit is drawing right now, total amperage that's being used. I can see the voltage that I have. The temperature outside 74.84. Relative humidity is about 99%, and the dew point 74. It has an environmental graph. I was running this earlier, and you can already see where the dew point has crossed the temperature, and when that happens, you can go outside and count on wet grass and equipment getting damp from dew. So it's going to be a dew-filled night. Then you also have power graphs that show the power on your mount, and it kind of edges itself along throughout the night, and you can see if there's anything crazy going on. This always happens when you start up. So let's go back to power. We really don't need this anymore. I'm going to connect to my mount by using the ASCOM driver for EQ ASCOM. And this is my virtual hand controller. I do not use hand controllers on the mounts. I don't even know where they are. They're in this room somewhere. I do use a hand controller for the Celestron mount because I use that for solar imaging pretty much, and I'm outside with that to get it set up, and I'll use that one for sure. But then once I get inside, I use a virtual hand controller. Now we're going to take PhD2, which is the guiding software that I use. As good as these mounts are, they have a lot of imperfections in the gears, a lot of slop, backlash issues, and so it's helpful to have a software that'll help compensate for that and to help keep your star pixel on pixel, so that when you're imaging for long exposures, that you've got a mount getting corrections, and PhD's what does that, corrections to keep it centered. I'm going to connect this equipment, and went too fast on that. I'm connecting the Starlight Express guide camera. It's the Lodestar, and I'm connecting the mount to PhD2. So now PhD and the mount can talk, and PhD can now send corrections to the mount when corrections need to be made. I'm going to bring up a planetarium software called Cortez du Ciel. I can't pronounce it, but this is what I will connect my telescope to. And why I use this software is because it takes very little memory on my hard drive. I have Stellarium and Starry Nights version 8, but and I like both programs, but they just eat up a lot of memory, and I don't have it on my outside laptops. So I'm just using Cortez du Ciel, and it works just fine. Right now I'm connected, and you can see that I'll spin this around, that the mount currently is pointed at well, it's at the celestial North Pole, which here's Polaris, which is where it's supposed to be pointed, and it's right where it's supposed to be. Then we're going to bring up my acquisition software, which is Sequence Generator Pro, and I'm going to connect the camera. I'm going to connect the filter wheel, the moonlight focuser. I'm going to connect the software to the mount, and I'm going to connect outside the Pegasus weather station, which is just really nothing but a sensor attached to the Pegasus. It comes with the power box, and it calculates the dew point by measuring the humidity and the temperature, and it knows when it knows when to turn the dew heaters on, and just how much power needs to go to the dew heaters. So it controls the dew heaters, and otherwise, if I didn't have it, the dew heaters would just be turned on and be going full blast all night long, which isn't so bad if you're on AC, but if you're using remote battery power, then that draws a lot on your battery. So the Pegasus really helps to manage that power. Were I going to image, I'd go ahead and turn on the camera's cooling system, and I would start cooling the camera, preparing it for an imaging session. But I already know that there's just too many clouds out there to try it tonight. I was hoping, but it isn't going to work. So I'm going to go ahead and disconnect. Well, I'll tell you what, I don't have a whole lot of time, but let's go to Cortez du Ciel, and let me spin this thing around, and let's look south. And let's say I wanted to slew here to this star, and I don't know what Bet-lib is, but we're going to slew there. So I'm going to connect to this slew icon, and let's go outside and check the telescope, because we have closed. Let me turn it back on again. The telescope is slewing over towards that star. And so it's where it's supposed to be. It's right on the meridian, so as you can tell, it would have just done a flip, because it was just on the west side of the meridian, the southern meridian. So we're pretty much horizontal, and it will right ascension move this way throughout the balance of the night if I were imaging that star. So we are going to park the mount now. I'm going to bring up my virtual hand controller and just go down to the bottom, click on park. I'll go back to my camera and make sure that we're coming back to park. I keep two outside cameras, as I think I mentioned in the earlier part of the presentation. One aimed at the sky to see what the clouds are doing with IR turned off, and this one has the IR turned on, and it lights up my backyard. It does not interfere with my imaging at all. Now, if I was imaging right into that camera, the IR would affect it. But it's on a fence, and if I was imaging into that IR, I'd be imaging into the fence. So that ain't going to happen. Not by design. Okay, other than that, turning all this gear off just means doing the same thing but backwards. And as I disconnect everything, I go through the disconnect process, and PhD, I'm just curious. I'm going to start looping and see how many clouds are back there. Plentiful clouds. So we're going to stop this and disconnect. So we've disconnected PhD2. I'm going to drop the driver, disconnect from there, and we're done. And then I'll go to Pegasus, and I'll turn off the mount, the focuser, and the camera, and I'll disconnect power. And I am completely separated now, power from my kits. What I would typically do is go throw the umbrella up over them and go to sleep. Wake up tomorrow morning and throw the telegizmos on each of these kits. If there is the chance that there might be rain, and in the summertime, then it's almost always a possibility. If I'll put the kits on if it's not too late. But a lot of times I start the imaging session, I just go to bed. I wake up and my fingers are crossed, and I say a prayer that we don't have one of those unexpected showers in the middle of the night. So far I've been blessed and it hasn't happened, but it can. Okay, now I think we can take questions.